Here we have the start of the revision exercises. Chapter 5, a particle is thrown upwards from ground level with speed of 10. And we have the need to find out its greatest height. And it's telling us to use this formula, v squared is equal to u squared plus 2as. So we have its speed. We can say that the speed is 10. It's thrown from ground level, it has to start at 0. Plus 2, and it's telling us to take gravity. Does it say take gravity? It does, yeah. Use gravity is 10 in this question for some reason. 2 by 10, because you guys can't use 9.8. Seems ridiculous, but 100 is equal to 20s. So the greatest height is equal to 5 meters. Then it asks us to use the principle of conservation of energy. So my mgh and my half mv squared is my principle of conservation of energy. So let's have a look at this. The mass by gravity, it starts at 0 plus a half. Its mass by its speed squared will have to be equal to, what happens then? It goes up. We don't know how high, so this h will be the greatest height. And at some point when it goes up to its max height, the speed will be 0. So we have our two zeros, so it's just a half mv squared is equal to mgh really here. And then just fill in our information. A half of the speed squared is equal to g, which we're told to take as 10, times h. A half of 100 is 50, is equal to 10h. So we can see again that the greatest height is equal to 5 meters. And then if the particle experienced air resistance, well, that's an outside force as it ascended. Why would the principle of conservation not apply? And you just write down here outside force involved. Therefore, principle of conservation of energy does not apply. ... You write the rest of that. Question 2, we have part A, state the principle of conservation of energy. The total amount of energy of a closed system remains constant. Unlike the previous one, it was an external force, and though it may be converted from one form to another, is the conservation of energy the principle of. This diagram here, I'm not sure it appears in this question, but I'm not sure whether it's just from the previous book or not. So let's just do the question and see. It is about a ring on a circle, which looks like the diagram that we have, but we're told here our initial speed is the square root of gr. So a smooth circular wire of center O and radius r, so I'll just put an r here, it says 5 in the diagram, is threaded on a wire. The ring is projected from the lowest point, which we have down here, with a speed of u. 1, the kinetic energy at the moment of projection. Okay, let's look. Kinetic energy is a half mv squared. A half m, we're just given as m, by v squared, which will be, this guy to be squared will just be 3gr. So that's going to be 3mgr over 2 for kinetic energy. Then we're asked for the greatest height reached by the ring in subsequent motion. Okay, let's have a look at the greatest height. So we have our kinetic energy and potential energy in position 1 and 2. Let's look at 1. And we have our kinetic energy, 3mgr over 2, plus mgh for potential energy, which the height is 0. So that's going to be equal to the greatest height reached, this mgh in position 2, plus a half mv squared. So my kinetic energy, when it reaches its greatest height, the 0 will be there. So we have our zeros will cancel, our m's will cancel, our g's will cancel. So the height reached will be 3 or over 2 for the greatest height in part 2. And then the speed of the ring when it's level with O. Okay, if it's level with O here, this height is the same as the radius. So let's use that information up top. take position 1, my potential energy, and my kinetic energy, mgh, plus kinetic energy of chip 3 mgr over 2 is equal to the height reached will be mg or, because of the level with O, and we're looking for the speed, so the half mv squared, the v will be our speed. So I think I'll get rid of the fractions. Let me multiply by 2 to get 3 mgr is equal to 2 mgr plus mv squared. If I divide by m and bring my 2gr to the left, I'm going to get 1gr, or just gr, is equal to v squared. So v will be equal to the square root of gr, and that will be in meters per second for question 2.